Oh, okay.
It took us a while to find the 2020 book.
Eagle eye there. So, hello, my name is André. I work for Beyond Pricing. We are a startup in San Francisco that we do smart pricing for Airbnbs. If you have Airbnb and you want to increase your revenue, for instance, if you don't know what is the rate by night that you should have on that specific month, we automate that. We collect data and we have an algorithm, our secret sauce, and we push automatically for Airbnb and we integrate with more 10 integrations. This is my second time here at Porto. I know these guys since Sam Drive. It's a good community. And I'm a software engineer at Beyond Pricing, but I'm more focused now in the data pipeline for the algo stuff we have to ingest data and make them available in the platform. So, yeah, bad news or good news. This is good and bad. Good for business. We have 22 terabytes of data in a single table. But it's a problem because our website uses that table. Our business intelligence teams, and sometimes you need to add a new field, we need to fix data. Yeah, like when you have a problem in the pipeline and you realize that you fucked up all the fields in this table, it's bad. It can take like 1 month or two to fix all the data. So it's you have some kind of challenges that are not trivial, So I will talk about specific problems and I will present the tools and I'll do live coding. Like this should be like a very pragmatic talk. I ask you to ask questions if you don't understand anything. I will go slow. So the first problem is, imagine you add a new field to the user table. It's called, I don't know, minimum age. And the default is 10. Okay? You cannot do update users set that field 10 because it will lock all the table and nobody can write anything. Okay? So I will show you the first solution for this problem. Just drink some water. How many of you had this problem in your companies? You. How many terabytes? How many gigabytes? Couple? Okay. 10. Okay, cool. All right.
Just a question. So we need to add a new column to the table. Is that
And you need to set a default for that. Okay. Or you need to fix like all the values on the table should be like this. Okay.
Are you gonna do the live coding on the production table as well?
Sorry? What? I don't get. Okay, so the first thing, can you see my code? Yes. You have like lib, backfill. Hey, the names are not the best, but you understand, okay? Let's import the table batch iterator, okay? I also need to import some connection stuff in Django. All right, let's create the iterator. I will show what is doing behind, so no worries if you don't get everything. So the first parameter is the connection. It's a Postgres connection in Python. We need the table. It's beyond users. Okay. And finally, we need the batch size. Like, I want to process 1,000 rows each time or something. Okay. If the batch size is too big and you are locking the rows, you can have problems because the probability of someone eating that rows while you are updating, it's more, So batch size, let it be like 500. Okay, let's do like that.
And if the batch size is too small, it's going to take too long?
Yes, exactly, because of the runtime trip of each request to Postgres. Okay. Thanks. So this guy is smart. All right. Let me just check something. Okay. So what this does is like this: begin ID, end ID. Can you see it from there? This is a Django shell behind. Yeah, I'm lazy. No, whatever. All right. So this iterator will give ranges of IDs. Okay. So imagine the following table. We want the last name of everyone be Freitas. Okay, it's a cool name in Portugal. It's from a stupid guy, you know. Every guy that is Freitas is stupid. It's dumb. Let's put it that name. But let's do it in batches. Okay. So going back to the code. Let's create a cursor. So this is a regular SQL will do, right? It will log all the table, bye-bye, uptime, DevOps team mad with you, you know? So we will filter by the ID. Thanks, you're my linter. All right, so yeah, I believe it's all. Let's do it. Let's see how it goes. Okay, it finished. Everything is Freitas, okay? So, okay, this solved the first problem of let's update the table without locking everything. Let's go to the second problem. We don't know the progress of this, right? If it's a peak table, how much it will take? Like 1 week, 2 weeks, 3 weeks? I don't know. So let's use a calculator of eta. Let's create it here. So what this, oh no, it's not this. The only thing that this eta calculator needs is the amount of work to do. That it will be the total number of batches. If it's 500 each time, it's the total amount of rows divided by 500, it's the total amount of batches. Okay. Is this a piano playing in the background? It's very, very classic. All right. So the iterator contains a property that is total at batches. Okay, it's there. We don't care about the implementation. It's there. Okay. And yeah, let's use it. So we say eta calculator start. Each time we finish processing a batch, we do eta calculator update progress and print. it's just one task done, right? If you are measuring not the amount of batches, but rows, we also could do that. But here will be like total amount of rows, okay? And then when it finish, say done, and we print the total time. Okay, so are you following up? Any doubts so far? Okay, let's use it. Oh, it was too fast. Let's put some throttling here, okay? So you can see. All right. Let's sleep like 0.3 seconds.
Is the ETA a measure of time or a percentage? What is the?
It's both. Like it's saying how much will it take to finish and the progress so far. Okay.
Does it assume that each update takes the same time?
Yes, it divides like the total amount of work done by the total time spent. Yeah, it's like a simple math behind. We can improve this. Like there should be like scientific papers about what is the best way of computing it, you know. But yeah, it's a simple implementation. So I have a question for you, like for the Python guys here. How many Python guys are here? Okay. 3, 4, 5. Okay, cool. What we can do, like, I will increase the time, 0.5. It's taking, no, it's perfect. Okay. It's taking 17 seconds. What can we do to improve this? Anyone?
Like take the throttle, take the list.
Yeah, that's a good. Now, but imagine that is the actual cost of updating the batch. Like you cannot do anything.
Blockchain.
Blockchain? Ah, come on.
We can increase the batch size.
Okay. Yes, let's increase. Let's see how it goes. 2000. Yeah, 4 seconds.
The sleep issue, if you multiply the sleep time by 4 as well.
Okay, this is a good idea, but another one.
Parallelize, do you have multiple predictions?
Yes. This guy is. You are smart, man. You are smart. Oh man, I love you, man. Okay, so let's do it. Let's extract this function. This one. Yes. To another method. Update batch. And let's use the multi-processing pool.
Couldn't you also reuse the cursor?
Yes, maybe. I don't know. Yeah.
Isn't that cheating, though?
Yeah.
I'm using the multiprocessing because the sleep doesn't actually bother the database, right? It's running on the other
Yeah,
side.
exactly. But my point is showing how can you use the iterator and using multiple processes. That's the point.
But it does defeat the purpose of having of preventing the lock, right?
Sorry?
It defeats the purpose of preventing the lock of a lot of rows.
Yeah, that's why you should tune the batch size, like smaller batch size to process.
Because I mean, if you're running two instances at the same time, there can be like double the batch size locks, which is not the idea, right?
So that's we can like if you want, let's say 400 batches at the same time. Like you go use 100 batch size and do 4 processes, and I have 400 batches being locked at the same time. Something like that. Like yeah. All right.
The delay for every lock will be slower if you take the 4 locks in parallel, right? If
Yeah,
the
but
server can take 4 connections at the same time.
But those rows are still locked.
Isn't it the same as having a bigger batch locked for instead of 4 smaller batches locked at the same time?
I think it depends on the database server as well.
Yeah, I don't know how those locks work internally, but
When I will show how to lock for a single row, I'll show with Django. At this moment, we are not doing anything. Like anyone can write the last name, and we don't know. All right, so we have our pool for processes. We need to change this because it will give the bound a tuple. Okay, yeah, I believe it's all. Nothing I missed. Oh, no. Four seconds. 4 seconds for the batch size of 500. So let's see one process. How it goes. $70 seconds. Okay. So this makes a big difference. I was doing a backfill and doing a save for each entity, and the ETA was like 1 year. With this approach, just 7 days. But then the problem was Postgres. It couldn't handle this kind of requests, similar requests. So I needed to slow down and less processes, doing some throttling, you know. That's it. All right. So, all right. So yeah, I was talking about this. So updating row by row takes a lot of time. Let's do another thing. Like this example is simple. Like you know what should be the value of this new column, but imagine that you need to compute the value based on an existing column. Let's call it a V2 column that contains a different business logic. Okay. So what we'll do is a simple thing. We will reverse the first name, and the last name will be the reverse. Simple as that. Okay.
So that means you've given this talk before. That's why your table already was like that.
Yes, I tested my own, this morning, and everything was working. So I expect that no bug will appear today. Let's see. But we have smart guys here, so they will help me on this journey. All right. Let me just. All right. So first thing I will do, I create another class, and it's called the batch update builder. This class will generate a complex update statement that says for this ID, the new value should be this. Okay, and what this needs is just the table, the name of the table. Name of the table and the ID ranges, and then let's get the users. When I'm doing select for update, it means this will be encapsulated in a transaction also. Transaction atomic. This is the way of starting a transaction in Django. Okay, and it's from transaction. All right. Okay, so this batch update builder is like, you can do, to update the fields, you just do like this. Update the ID of the user, the field you want to set the value, and the last name will be user, first name, yeah, that's it. And then we build the update SQL. And instead of doing this SQL statement, we do this.
Can you show us the string that's generated in the SQL?
Yes, I will show, I will show. Thanks for remembering that. It will be this one. No, this if should be here.
When is it not going to be there?
If you deleted some data from the table, and you are still trying to get ranges from there, it can be empty, that range. So it happens. That's why you need to check if you have data to update.
I think you didn't think of it, you noticed it and bit you and then you started.
Yeah, exactly. Okay, let me check. So, batch update builder, the table is beyond users, begin ID, end ID. You are getting the users, selecting for update, it's in a transaction. We are filtering by the ID ranges. We are reversing the first name. Update SQL is here. This one. Yeah, need to import. It's here.
Line 30, there is a double indentation.
Sorry?
Is line 30 double indentation? Is it the 40? 30. 30.
30.
Yeah.
Oh yeah, oh thanks. All right. Let's see if it works. If not, yeah. I need to import the user. This is the SQL is generating, you know, where ID equals 3, it'll be like this. If not, it keeps the same last name on that table. Okay, so far, yes. Did you ever use this kind of update statements? Switch cases in like SQL, Postgres? Yes? A bit, all right. Yeah, so this was like the huge saving from taking 1 year to 7 days, this stuff. But I need to invest on this SQL builder and the iterator, but it was worth it. So yeah, let's go to the final problem. So if this takes like 1 month and your database administrator wants to do an upgrade of Postgres and needs to do maintenance, why do you tell them? Say, hey, wait 1 month and we talk later. It's bad, right? So I'll ask you what you will do to still be able to process this kind of data and resume the process, pause and resume the process. What you will do? Can you give me some ideas?
Each batch is independent, so you can just process batch by batch and pause it whenever you want.
And you save the last batch, process it? Okay. Okay. That's it's easier if you do a single process. If it's multi-process, like can be forward or behind, you know?
Can't you just change the query to only find the ones that are still outdated and then just kill the process if you need to?
But that's in a big table will take a lot of time.
You can always
Yeah, sure.
That's the problem.
I'm not saying it's ideal.
Yeah, but it's a good idea also.
You can save the patches you already processed instead.
Yeah, exactly. Where?
In another table.
Okay.
Can't that get outdated if something changes between when you stop and when you restart? If something...
It should be like, I'm assuming your process of fixing data, it's idempotent. You can run multiple times. It's the same, like you apply the same business logic, whatever the input is. Like if you are creating a V2 field, a new field that contains a new business logic, it can be always computed from the current state.
Yeah, but what I was thinking was, if you do it by storing which batches you already processed, you're assuming the ones left are the ones you still need to run the second time, but something may have changed and new records added in between for some reason.
Yeah, if it's just the ranges, like you don't save the state, it's just ranges, you know. Don't save the previous state. It's not a problem, right? But that's a solution. That's a solution. Good idea. Like what I did, like I wanted to have a queue system where we can enqueue the ranges, and then also want to be able to parallelize this, so we can have like multiple queues by process. And then each process will update the database, as you see here, the same SQL query. Okay. What I found in Python is an implementation of a persist queue. Did you use Kafka or something before? Anyone Kafka? What's the big difference between Kafka and like Rabbit or something?
Rabbit engine?
Yes. It's being able to commit the offsets. Like if the process that crashed while processing something, it doesn't commit the offset in the queue, the element is still there. So you restart again and process again. And this implementation does the same. I was sending a message to Pedro saying, hey, I will implement Kafka in a file system, directly with files, just no network. And then I found this cool guy that did that. So I just need to implement this partitions logic and then assign for each process the partition. If I'm taking too long, I'll be faster. Okay. Let's see if I can show you. Like this code is getting complex and more complex to understand for you also if you are waiting for the dinner. But let's see. All right. So first thing is called persistent queue. Partition it, not partition. Let's create it. The number of partitions should be the same number of processes, that is 4 at this moment, okay? All right, so first step is enqueue the jobs, enqueue the ranges, okay? Let's enqueue them.
But the process will put only one.
Sorry?
You start with only one that will.
No, thanks. So I need to clean the queue so we can enqueue multiple times if you want to repeat, okay? So we will enqueue the ranges in the table batch iterator. We have a property that is called the cycle queue. So I'm doing like a enqueue with a single process. So we need to do load balancing between them. So this will cycle all over the partitions to enqueue. All right, and it's done. I will extract this to another thing.
Isn't that supposed to be queues of create?
Line 39.
Yes, thank you. You're the best. You're the best, man. Not here. On top. So, okay. We created the 4 queues. All right. And then let's enqueue the jobs. It's in queued. Okay. Well, let's do the second part. Let's process the partitions, process the jobs. So instead of calling in the pool the update batch, we call process per partition. We will do range of 4. It's the same number of processes, you know. So this time, instead of using the cycle queue, this is a load balancing queue, we will get the process queue. That is the one that is assigned for that process. Okay.
And how does it know which queue is that if you're not passing it the partition number?
It uses a counter in Python that is a synchronization mechanism for multiprocesses. So each time a process wants a partition, it will increment the counter, partition 0, 1, 2, 3, and then memoize for each process. It will save it. I can show you later the implementation if you want. And then we get the ranges from the queue, we process, and then we say, queue, tasks are done. If it crashes here or something, they are still in the queue. Okay? Well, I will leave it so. Let's see. I need to do something. I forgot. We need to close the connections before doing multiprocess because they will have like concurrency problems. So each process needs to create a connection. It didn't fail so far because of luck. Like, you're lucky. Come on. So that I confirm it worked, the stuff. But I'm not lying to you. I can like stop the process if I want. Some of them will be processed. And then I can go here again. And we'll resume the work, okay? The last batch, okay? And yeah, that's it. Like, my goal was to describe these problems, like being able to process in batch, being able to see the progress, parallelize the fixing scripts, and use queues to be able to pass and resume the script. I hope you liked. It was my first presentation on these tools. Maybe we'll need more time. Sorry for the next guy. And yeah, come talk with me and talk more about this if you want and about beyond pricing. Okay. Thanks.